this we will see this the next problem, which is longest finding longest palindromic substring. So given a string, return the longest palindromic string. So in a string we have to return the longest palindromic string. So the palindromic is the string which reads same from both sides, like starting and ending. For example, here BAB is palindrome, because if we read from starting it will come BAB, but if we read from ending it will come BAB. So this is called palindrome. And the substring is a continuous non-empty sequence of characters within a string. So let's see our the problem. So in this we will see the method 1 and method 2, which are very similar, and the method of 3 and method 4, which are little bit similar, and only the method 1 and 2 are working fine. They are testing all, they are passing all test cases, but uh, the other two test cases are not passing all the test cases. So but we will see like the how we have implemented logic, so that you will get an idea. So yeah, let's go through our solution. So here we will see the example 2. Here example 1, here we have BABAD as input. We have to return the longest substring, which is a BAB. So and also ABA is also a longest substring, so that is also a valid one. And the second, in second example we have CBBD, the longest substring is BB. So here the constraints are string length is between 1 to 1000, and string consists of only digits and English letters. So this is a dynamic programming concept. So this involves dynamic programming. So we will see the solution for this. So the first solution, in the first solution, what we are going to do is we'll be iterating through the string each character. So here I have taken the our given input, and in each character we will be iterating, and we'll be finding out the longest palindromic string. So initially, like we get this string B, which is BABAD here, and here we excuse me, I will just yeah. So initially we get the string BABAD. So we will initially assign longest palindromic string as a just empty string, and we will iterate, we will run a one for loop throughout this length of the string. So assume like here this table, all these tables I'll explain you like while going through program. So we will iterate through the string. So we will inside it, we will recursively call one more function, which is longest palindromic helper. One is for covering the string length odd case, and one more is for covering string even length case. So for example, in first one we are covering like if the string is here odd length, you can see the length is 5. So in this case this first case will cover, and the second case is covered for the strings length which have the length of 6 or even case. So initially we get this string and we go inside for loop and we will be iterating through each characters, and here we are calling the longest palindromic string. So here I'm covering for odd case, and here for I'm covering for even case. This is just a visual representation of each for loop iteration. Like this is iteration 1, iteration 2, etc. till iteration 5. And here so in and also the here I'm covering the LPS, and longest palindromic string LPS is even longest palindromic string. I'll be covering those two in these two variables, and long palindromic in long palindromic string I'll be covering I will be storing the longest palindromic string. And next while returning we'll be returning this longest palindromic string. And here I jk values I'm covering here, so you can look at this. So while going through the program you will get to know about this one. So initially we get the string, and we will start at beginning. So I is 0 0. Yes contains string, and 0 0 we are sending string 0 0. So initially we get here j and k will be 0 0, because here we passed here 0 0. So here we get 0 0, and we have started at the let me just annotate it. Yeah, we have started at b. And from here when it goes to the longest palindromic helper, it will check these conditions. J is greater than or equal to 0, and k is less than length of yes. Both are true, and s of j and s of k is whether they are equal. Though those two are equal, so because s of j and s of k represent the same character, so those are same. So it will go inside while condition, and j becomes negative. J becomes j equal to -1, which is will do -1, which becomes -1, and k we do plus, so it becomes 1. And then when it comes to again next iteration, these conditions becomes false. Here j should be like greater than or equal to 0, but it is -1, so this condition becomes false. So it will not go inside while condition, it will just return the s of j plus 1 k, which is s of 0 to k, which is 1. Means here s of 0 1 means just a, it is returning just b, it is returning just b first, which is first character. So we get here first character. Here we get first character in odd LPS, so that is what I am storing here, odd LPS. And then here it will check odd LPS is greater than longest palindromic string. This is true, so in longest palindromic string we will be storing the b. And next we will be covering even case, where this is even case. So we'll be here passing I and I plus 1, which is I this 0 index and 1 index. So it will go here, and here we get j equal to 1 and k equal to j equal to 0 and k equal to 1. And initially itself this conditions becomes false, because these both are not equal, so this will not go inside if while condition. This will just return s of j plus 1 k, which is 0 plus 1 is 1, so s of 1 1 colon 1 which is none, so it will return none. So here we get in even LPS we get none, and even none like this tree is which length of this is greater than the longest palindrome. This is false, so will not go inside. And we'll go to next iteration, which is the second iteration. We start from second index, which is a, and In this case we will be passing 1 comma 1, so that is what we get here, 1 comma 1. And we check 1 comma 1 is 1 comma 1 is these conditions becomes true, and s of j k is true because a is equal to a itself equal to a. So this will the first condition in this case is always true, becomes true because we are passing I comma I, so the same character. So here this becomes true, so we'll be subtracting 1, it becomes 0. And here we for k value we are adding 1, which is becomes true, which becomes 2. And then next we will be checking 0 zeroth index and second index value, character at second index. B comma B and B is present, is same, yes. So again it will go inside if while condition here, and again it will subtract 1, it becomes -1 and it becomes 3. And then next this condition in next iteration, these conditions becomes false, so it will come back, and here it will check the length of the returned string is greater than the current longest palindromic string, which is the length of the current palindromic string is 3. So this is true. So in longest palindromic string we will store BAB. And next we will be checking for even case where we are covering character at a1 and 2, which is a and b. Here this condition becomes again false because a and b are not equal, so we'll be returning s of j plus 1 to k, which is 2 to 2, s of 2 to 2. So again this is just null, so again this will not go inside if condition, so it will go then it will execute the next iteration, which is index 2. So it will again start at b. So b which is index 2. So okay, initially j and k will be 2 and 2, and initial condition becomes true, so that is the reason subtracting 1 and adding 1, it become 1 and 3. We will be checking 1 and 3, it is true again. So again it will goes to inside while condition and subtract 1, which becomes 0, and here 4. 0 and 4 equal, that is false, so we will not go inside while condition again, and we'll be returning just s of j plus 1 k, which is s of j is 0, so s of j plus 1 is 1. S of 1 to 4, which is 1 to 4 is ABA, so we will be returning ABA. So we got here ABA, and again we are checking here the odd LPS is greater than the current longest palindromic string, false, so we will not go inside if condition. And we check the even condition where we are passing B and A, which is 2 and 3. Again 2 and 3 characters 2 and 3 is not equal, so we will not be going inside this while condition. We will just returning s of 3 to 3, which is null again. So here which is again null, so we will not be going inside if, and we'll be continuing next iteration, which is evaluate index 3. So again 3 will be passed, here we get 3. Initially this is true, so it become true 4. Next it will become false because 2 character 2 and 4 are not equal, so we'll be returning here 3 to 4, s of 3 to 4, which is 3 to 4, which is a. So here we get a, and next for and it will not go inside this condition because just a length of a is less than the our current maximum palindrome, which is 3. So we'll check for even case where we'll be passing 3 4. Again this condition becomes false, so it will not go inside this, and it will again return null character. and we will be continuing the next iteration where we start at index our index 4 and D again. We'll get 4 and 4, initially true, so 3 5, and again 3 5, it will check 3 5 condition. This condition becomes false because k should be less than L length of yes. So we'll be not going inside while condition, and we'll be passing just s of 4 3 4 to 5, which is 4 to 5 is D. So that is the reason here we get D. And for this case again we'll be passing 4 4 and 5, I comma j, we have passed 4 and 5. So 4 and 5, this condition becomes false here. So that is the reason we'll be just returning s of 5 comma 5, 5 to 5, which is just null again. So we get null. So at the end this iteration becomes completed, this for loop ends. So by that time in longest palindrome string we still have BAB, which is the longest palindromic substring in the given string. So this is the logic of this method 1, and the time complexity is order of n square. The reason is here this will take the it will iterate through the given string, so which will take order of n time, and the internally it will call the longest palindrome helper, which will take the maximum. In worst case it will order of n. So that is in worst case also it will be like a maximum n by 2, but we consider the highest term, which is n. So the outer for loop is n, order of n, and the internal this function takes order of n. So that is the reason time complexity is order of n square, and the space complexity is order of n, because here we are using longest palindromic string, which is maximum. The longest palindromic string maybe the given string itself, longest palindrome, given string itself palindrome. So in that case we get order of n. So that is the reason space complexity is order of n. So yeah, this is the concept. Let me just see the second method, which is second method is very similar to the first method. So just you can see here it is very similar to the first method, just instead of using the string, here we are using the just indexes. Like instead of here passing this string, we are passing just the length, and using that length here we are finding out the longest palindromic string. By this we are decreasing the space complexity. So we will see this one. So the logic is same. So here you can see this table will be same for this table, and this table will this table and this table will be same for method 2. It's just this table will varies. So here we are taking odd LPS len or even LPS len, longest palindrome len. So initially as we have seen here, j and k, like we are doing everything is same. Here just in this internal function we are returning k minus j minus 1, which is the length. So here k minus j minus 1, which is 1 minus 1, which is 1 minus of minus 1, and minus 1, which is 1. So at this place the character length is 1, as we have seen here 1. So and here for second case, which is the even LPS case, we got 1 1 minus 0 minus 1 1 minus 0 minus the 1, so 0, it will become 0. So the maximum of these two is 1. So here we take maximum of the two current current maximum we get here, and we check current maximum is greater than the longest palindrome length, true. So in that case we store the maximum in longest palindrome length, and we check here if which is um, like larger. So in this case in odd LPS length and even LPS length, the largest is odd LPS length, so we'll go inside this condition, and we subtract, we take the index, like since if we got the index of the first and the length, that's enough to look at the longest palindromic string, because index to length will be the longest substring. So here we are finding out the index, which we get from I minus current LPS. He since current since in current LPS we have the uh, like current string highest length. So um, if we do the half and subtract from I, we get the index, because initially it for example, if you consider here, it went at this for loop, it went till A and till B, till here it goes like 0, it will go till 0 and till 4, and we get we it will while returning, it will return 4 minus 0 minus 1 here. In this case you can see we get 3. So uh, if we make half, then it will become 1. So because double subtraction becomes like it will make it 1, and if we subtract 1 from this index, then we will get the that this index 1. So that is the reason here we are doing this thing. So let's see the logic itself here. Initially we got this one, and here we got 1, the maximum is 1, and we went inside this condition and also inside this condition. 1 by 1, 1 by 2 is 0. So 0 minus 0 is index 0. So initially our index we had 0, and we again got 0, and in next iteration we are passing it will start from this condition. So at this stage 3 minus of minus 1 and minus 1, we get 3, and 2 minus 1 minus 1, 2 minus 1 minus 1, I think you got it. So 0, so maximum is 3, and again current will be replacing this longest palindromic with maximum 3, and we'll be going inside this condition, and again 1 minus 3 by 2, 3 by 2 becomes 1, 1 minus 1 0, so again 0, and it will go to again next iteration, which is 4 minus 0 minus 1 3, and this is 0. Maximum is maximum here we again get like in current max we get 3, but it will not go inside this if condition, becomes because 3 is greater than already in longest palindrome length is 3, so and current LPS length is 3, so it will not go inside if condition. And even for the next iteration also it will not go inside, because we got the longest is 1, because 1 maximum of 1 and 0 is 1, so it will not go inside this if condition. And in the next iteration also this will not go inside this if condition, because the largest of 1 and 0 is 1, but we already have 3, maximum is 3. So that's how we'll be having in longest palindromic length we'll be having 3, and index will be 0. So index it will start from 0 to it will go length 3, so this will be the longest palindromic string. So here we'll be returning the same thing, which is it start from 0 to index plus longest palindromic string. index plus longest palindromic. Long is it will add 3, so that's how 0 plus 3 is 3, so we'll be returning here B A B. That's how we are returning the longest palindromic string here. So yeah, this is the second solution, and here also the same time complexity is order of n square, because the external for loop and internal one more function which takes the n, and time space complexity is order of 1, because here we are using the constant variables, constant number of variables, so the space complexity is order of 1. Let's see the quickly see the third method and fourth method. So third method and fourth method are like somewhat similar. So what we are doing in third method is you can like if you want you can skip this, because these two methods are not working properly. So if you want you can look at the concept, but this method is passing only 95 out of 141. The further remaining test cases it is giving timeout error, and the second one is it is passing only 119 out of 141 test cases. So we will see the what we are doing here. So initially we get the string, and here what the concept is the simple. So initially we get the string. So what we are doing is we take the let me just annotate it again. We just take at the this we will take only a b a d here, and assume that is as a that is a largest palindrome, and here we in this case we have not consider first character. In this case we will not be considering last character. So that's how we are continuing recursively continue. In this case again we haven't considered first character, here we haven't considered last character, again same here. So we are recursively doing all the same way. Same here, you can see uh, here we haven't considered the first character of this string, and here we haven't considered the last character of this string. So that's how we are doing the same thing, so recursively. So that's how we get every string formed by this string. So we get every string formed by this string, but here we should not consider these cases, because here we should not consider this circled one b, because and one more thing, like in iteration, recursive iteration, we are checking if each string is palindrome or not, palindrome or not, and we are finding keeping track of the longest palindrome. So here we should not check this again, because here we have already checked this one, so we should not check this. If we check this it will become more time complexity again, so we are doing the same thing again and again and again. Same for this case, because here we have already covered ABA, we should not consider again ABA. And this same thing for this, we already covered AB and BA, we should not consider AB and BA. So that's how we should this is working. So initially we get this string, and we created here two one is array, one is dictionary for storing these characters, like for checking if already we have checked or not. And initially we are passing string 0 and length of the string, and here for palindromic helper we get the string L and H, and initially we check if this given string is palindrome. If the given string is palindrome, then we'll be storing at like and initially, like in this program we also created this array with for example you can see here we have created array with like here we are creating dynamic array with size of length. So this is what we are creating, And then next here this becomes palindrome. Is we are checking this is palindrome or not. This is false, so it will go inside else condition. And we are checking the already we are checking here already this length is palindrome. This will be useful in the case where for example here in this case if we find out in this case we find out ABA is palindrome, so we store in at index 3 we store ABA. So here BAB is also palindrome, so, but we will not go inside again and check we avoid of doing for all the case of 3 we avoid doing that. So that's how we are avoiding doing all this. We are avoiding. So initially it will check palindrome or not. This is false, so it will come here and it will check length of string L plus 1 to 1. This length is it will check palindrome or not. If it is not palindrome, if it was palindrome, then in at index 5 it would have stored BABD. So it is not. So like here we would have stored that. So this both conditions becomes false, so we come and recursively we call the longest palindrome helper again. And in this case you can see we are passing L plus 1. So initially we got 0 here, and here for this case the length of string is 5. So we got here at H we got you can see length of S minus 1, which is 5 4. We get 4 here, which is you can see this one 0. We get 0 and 4 initially, and recursively we pass here 0 3. We pass 0 3, and string L plus 1 to end, which is A to end we are passing. And in one more if condition we are again checking the same as is here, and we are passing here yes of on till H. So till H means we get till H means like we get till here only BA. So we are passing BA, and L same, which is 0 and 3. And in next iteration again it will check this string is palindrome or not. Again this is false, so it will again come here and it will check this condition. This both condition becomes false again, and we are passing again BAD and ABA. And again here we are passing 0 and 2, and again recursively it will come to this method, and at this place it will become again it will become not palindrome. So again it will pass ADBA, and recursively this will pass again DA. So at this stage again it will at this place this conditions becomes false, L less than H. So that is the reason here it will stop base condition, that is. So it will go back to till here, and it will cover all this and go back and comes here. So this is the palindrome. So at this stage it will come here, and at this place these conditions becomes false. So that is the reason it will not call BA again, because BA already we have checked. So after checking every time we will be storing in like if we'll be storing those, so we will have a keep track of those like already checked the strings. So we'll not be checking this, and we'll be checking AB because we haven't covered AB. So this becomes palindrome. So we are checking we are storing at index 3 we are storing ABA. And next we are going back BA. We'll be covering BA. ABA will not cover because already the length of 3 palindrome we already have, so we will not cover here. And we will not cover this also because we already have length of 3 palindrome we already have. Only we check a length of 4 palindrome, is it palindrome or not. So this is false, so we'll come back and at the end we will be having in array we'll be having the longest palindromic string. So here we are checking, we are iterating through the array, this array, and if there is any string, if 0, then we can't go move forward, and here there is no 0 at this place, so we'll be returning the whatever the string is present, which is the longest palindromic string. And this method is just a helper method for this method, which checks only the goal of this method is to check is it a string, given string is palindrome or not. If it is true, it will return true. If it is false, it will return false. And also it will store it will store in checked, it will store that string is that string already we have checked, it will store that information. Since in array we are storing only if the given string is palindrome, so that is the reason we are using one more dictionary, which is self-checked. So in this we are storing every strings, and we are storing true, which means we have checked this string or not. This will check only those conditions. Yeah, and coming to the next method, so the here you can see the same thing. And coming to the next solution, this is very similar to the previous method. In this case we are just using the queue. We will go through the solution. So here here you can see initially we get the string, and we are creating here queue using the dq. Dq we are importing from the collection. You can see here from collection we are importing the dq, and we created a queue. So this is queue. This is run as a stack, but this is a queue. So initially we append the given string, which is bad, and string we check. This concept is very similar to the graph problems. Like if you have seen my previous videos, this is little similar to the graph problems. So this is the concept. This is the same. It involves like scene and this condition of checking the stack until stack empty. We'll be doing something inside a while condition. This concept we have seen in, like, this is kind of way of solving the problem in graphs also. So anyways we'll be here checking if queue is there is queue is not empty, so we go inside and pop left, which is will be popping bad, and if this bad is present in current scene, this is no initially it is not present, so we are continuing, we'll be adding. So here we have added bad to scene, and then next here we are checking, like, this condition just reverse the current string, which is bad. It will reverse and it will become da bad, I mean, da bab. So it is checking if both string are equal or not. If equal, we are just returning here. So that's it. It will the program will end. In this case this is not equal, like bad is not equal to bad. So that is the reason we'll not go inside this if condition. So we'll be again appending to this string and this string to our queue, which is abad ba. Next queue is not empty, so we pop next element, which is abad. Let me just write it here. We have already popped this one. We pop this one, which is abad, and we check if it is present in scene. No, we will be adding abad to scene, and we are checking if abad is equal to daba. No, so we will be again appending its children, like its two characters, which is bad aba, bad and ABA we have added, and we pop the next element, which is again next element, which is BA. Again, for BA we check like if it is present in scene, no, so we'll be adding BA to scene, and we are checking if BA is similar to AB, no, so again we are adding its children's, which is BAB. I should not say children, but like we are adding current string of these two, like in this we are leaving the first character, in this we are leaving the last character, so we are adding the same two characters, two strings again, and again iteratively we will pop the next element. So we do the same thing iteratively. So that's how we get the longest palindromic string. At this place we get the longest palindromic string, and here we are returning the, like at this place we get the longest palindromic string, so we will be just returning that longest palindromic string. So actually we will not be checking all these things I have written, but will not be checking all this. At this place we get longest palindromic string, so we'll be just returning that. So this program will end here. Since this involves string, like we are covering all the substrings we formed by the given string, so all the substrings of a given string will be 2 power n. So this is a tree like structure. So as we have seen, if there is a tree like structure, then it will be 2 power n. There are 2 power n strings in strings or childrens of a root node. So that is the reason that we are checking 2 power n strings if it is present, if it is like palindrome or not. So that is in worst case, so that is the reason 2 power n into n time complexity, and space complexity is 2 power n, because we are storing those 2 power n characters. uh, uh, space complexity is actually space complexity is n, because here we are just creating array of size n, and here also the array in this case like it will become order of 2 power n, because in worst case it will go till here, till first character 1. So in this case the space complexity becomes 2 power n. So these are not passing all test cases, but due to time complexity. So but this concept I think it will be useful to solve other problems. Yeah, that's it, I guess. So I have shared the solution in here, so I'll share the link of this solution and the images that I have shown you I'll share the links of those images and this solution link in the description of this video. Yeah, that's it. Thank you for watching.